Hi. So if you have binary numbers in your digital system, what you want to do with those binary numbers is combine them in some way and do some mathematics on it, right? So for let's probably step back and look into uh, the decimal number system and what we do with it. So if you have a decimal number system and you say, okay, well, I want to combine these numbers in certain ways, you use certain operations to do that, right? And the operations, the primary operations that we do is additions, subtractions, multiplication, and division. And we use these operations to build an entire system of maths and to do processing with numbers so that we can derive information out of them. Okay, in a similar manner, we do this with binary numbers as well. Okay, and some of the operations for binary numbers uh, are these. At its most basic, binary systems have three operations. Okay, and these operations are called the not operation, the and operation, and the or operation. Okay, and let's take a look at each one of them in turn. So if you look at the not operation, if you take a binary number and let's just represent the binary number as a, okay, and you want to do the not operation on it, you denote it like this. You call it not of a. And what does not of a do? So we can represent the function of the not, and we call this, let's call it the not operation. But when you build it in physical systems, we actually call it the not gate. So a gate is a digital device that does a particular digital operation. Okay, so the not operation, how does it work? One of the ways you can do it is you can give it an input. You can give the input, and let's say the input is a and the output is not of a. So the not operation is a one input operation. Okay, so if this is the not operation, you have one input a and you have one output a bar, or you can call not of a. Okay, and what are the values that a can take? A can take only two values, right, in the binary numbers, 0 or 1. Now if the input is 0, not of a is going to be 1, and if the input is going to be 1, not of a is going to be 0. Does that make sense? So it's a fairly straightforward system. So if a binary number is coming, you get the opposite binary number because there are only two binary numbers. So if the binary number is 0, it becomes 1. If it is 1, it becomes 0. So that's what the not operation does. Now, uh, we have represented the working of the not operation by this table, right? And this table is called the truth table. So it tells us how the not operation or the not gate functions. The way it does it is it gives you all the combinations of input that is possible, and it tells you the output corresponding to those inputs. So let's carry on and let's see what how an AND operation works, and hopefully this will make a little bit more sense. Okay, AND operation is a slightly more complicated operation. In an AND operation, you have two inputs. So if you have an AND gate here, let me draw it in black. So if you have an AND gate here, okay, or an AND operation has two inputs, let's say A and B, and the output is written as, let's say, A dot B. And this dot is also called AND, so you can call it A and B. Okay, now how does this work? Now this is how it works. So we can represent the working of the gate by writing a truth table, right? And what do we how do what how do we write a truth table? We write a truth table by putting the inputs on the left hand side. We draw a line and we write the output here, which is A dot B. Okay, and what we want to do is we want to write all the combinations of the inputs that are possible. Okay, now you know that A can take either 0 or 1, B also can take two values, 0 or 1. And so what are the combinations that we can have? You can have the combination 0 0, you can have 0 1, you can have 1 0, and you can have 1 1. So these are the four combinations that are possible. So for each of them, now what you can do is you can write the output. So A and B, when the inputs are 0 and 0 is 0, when it is 0 and 1 it is 0, here as well it's 0, and here it's 1. So basically what A and B does is it is 1 only when A and B both are 1. Okay, if either A or B is 0, the output is 0. So how does an AND operation function? The AND operation works by looking at the two inputs, and if both the inputs are 1, the output is 1, otherwise the output is 0. One of the things that you will notice is I'm kind of all the time interchanging. I'm trying to be consistent, but I'm interchanging operations and gates, right? So an operation is a mathematical term, while a gate is the physical implementation of that mathematical operation. Okay, so just wanted to say that. Okay, let's look at the OR operation, and what I'll do is I'll just move to a newer page so that we can look at this operation. So here's so how does an OR operation work? Again, an OR operation similar to an AND gate is a two input operation. Okay, so if you have a gate here, if you have an operation OR operation, you have two inputs A and B, and the output is A or B. So this addition symbol represents the OR operation. Okay, and how does the OR operation work? We can again define the OR operation by drawing a truth table, right? So to draw a truth table, we put the inputs on the left hand side, and we put the output on the right hand side, and we write all combinations of the inputs. And in this case, there are four combinations, right? So you have 0 0, 0 1, 1 0, and 1 1. And in this case, the outputs are 0 1 1 1. Okay, so the way the OR operation works is the OR operation, the output is 1 when either A or B is 1. Okay, if A or B is 1, the output of the OR operation is 1. So in other words, A or B is going to be 0 only when both A and B are 0. Okay, hopefully that makes sense. So so those are the three fundamental gates that we have. You can have many more gates which are a combination of these three gates, and you can, for example, make a NOR gate, which is a NOT gate and an OR gate. So you have an OR gate and you invert the output of a OR gate, so you get a NOR gate, and so on and so forth. But we'll look at them in the next video.